Hello everyone, welcome to LeetCode Weekly, where every week we cover a few LeetCode problems. Here we have problem 3805, count Cipher pairs. We're given an array of strings called words, and there are n strings and every string has the same length m. All characters are lowercase English letters. We're allowed to apply the following operation any number of times. We can pick one string, shift every character in that string to become the next letter in the alphabet, and the alphabet wraps around, so Z becomes A. Two strings are considered similar if, after applying this operation some number of times to either string, the two strings can be made exactly equal. Our task is to count how many index pairs, I and j, satisfy I being less than j, and words I and words j being similar. So this is a pair counting problem, but the two strings don't have to start equal, they just need to be transformable into each other using uniform Caesar shifts. A straightforward approach would be for every pair of strings I and j to count all 26 possible shifts on word I, and after each shift check if it equals words at j. So there are O of n squared pairs, and for each pair we try up to 26 shifts, and each comparison costs O of n time. So our total complexity is O of n squared times m. N can be up to 100,000, and n times m can also be up to 100,000. That solution is too slow. Checking all the pairs takes too much time, and multiplying by string operations makes it completely impractical. So we need to avoid pairwise comparisons entirely. But here's a key observation. If two strings are similar, if and only if the pattern of the character differences inside them is the same, we can normalize a string into a canonical form. So we take a string and treat each first character as the reference, and for every character record how far it is from the first character, remembering to mod it by 26. So for example, with the string AB, we start A off at 0, and B is one character ahead of A, so the pattern is 0, 1. And with the string ZA, we start Z off at 0, and A is one character ahead of Z. So the pattern is also 0, 1. So even though AB and ZA look different, their patterns are identical, so they're similar. Once we group strings by their pattern, and if a pattern appears k times, the number of valid pairs inside that group is k times k minus 1 divided by 2. This avoids pairwise checks entirely. Creating the pattern for one string costs O times m. Doing this for all strings costs O of n times m, and counting pairs is linear in the number of patterns. So overall, the time complexity is O of n times m, and the space complexity is also O of n times m. This fits within the constraints, and is much faster than the naive solution. So we're first going to create a dictionary called groups. This is going to store how many times each pattern appears. Now we're going to loop through each word in the list. So for word in words, base equals odd of word at index 0. This is to get the ASCII value of the first character. And then we're going to create a variable called pattern. And this is going to be an empty list to store the normalized pattern for this word. For ch character in word, so we're going to loop through each character in the word, diff equals odd of the character minus base mod 26. So this computes a circular difference from the first character, essentially getting the difference from the first character and modding it by 26 to count for the wraparound. And then we append it to our patterns list. So pattern.append diff. Now we convert the list to a tuple. This is so that it can be used as a dictionary key. And if pattern in groups, we're going to check if this pattern already exists. Groups at index pattern is going to be incremented. Else we're going to initialize the count for this pattern. So groups at index pattern equals 1. Now we're going to create a variable to store the total number of valid pairs. So result equals 0. And then for count in groups.values, so we're going to loop through the count of each pattern group. Result add equals count times count minus 1 and integer divided by 2. This is going to add the number of pairs from this group using the formula from earlier. And then we're going to return our final answer, so return result. Now let's see if this works. There we go, and if we submit, it's been accepted. Thanks for tuning into LeetCode Weekly. If you enjoyed this video, then be sure to like and drop a comment down below. Thanks for watching.